All right, so this is topic 2. I'm going to do a fairly quick review of this topic. Feel free to pause the video, slow it down, do what you got to do. So it says find the gradient and the y-intercept. To do that, you have to put it into y equals mx plus b form. So right now it's not in that form. So we're going to go ahead and get this y by itself. So I like keeping the y's positive. So I would just add 4y to both sides. And then you get 3x minus 5 is equal to 4y. Divide everything by 4. Divide by 4. Divide by 4. So this cancels out, and then you're left with y is equal to 3 over 4x minus 5 over 4. And then we have to find the gradient. So the gradient, which is m, is equal to the number that's in front of the x, which is 3/4. And we have to find the y-intercept, which is our c. It's y equals mx plus c, my bad. In the IB curriculum, that's what it's worded as. So our y-intercept is going to be equal to negative 5 over 4. Okay, so those are our two answers for this question. Find the equation of the line with the gradient. So the slope, or the m, is negative 3 in this case, and it has to pass through this point. So I'm going to call the first one x1, the second one y1, and you're going to plug it into this formula. Y minus y1 is equal to m parentheses x minus x1. You could plug it into y equals mx plus b, but then you don't know what the intercept is, or the b. So then you have to find the b and then put it into the y equals mx plus c format. That's up to you. I prefer just to use this formula right here. So we have y minus our y1 is negative 4. So y minus negative 4 is equal to our m is negative 3. Parentheses x minus our x1 is 2. And then negative negative becomes a positive, so that's y plus 4 is equal to, I'm going to distribute this, so that's going to be negative 3x plus 6. And then to get it into this form right here, you have to subtract 4 from both sides, minus 4. So this cancels out and you're left with y equals negative 3x plus 2. And find the equation of the line. We're done. Okay. For the next one, find the equation of the line passing through this point, these 2 points. So x1, y1, x2, y2. So we're going to find the slope first, so which is y2 minus y1 over x2 minus x1. So I'm going to go ahead and plug numbers in. So 1 minus a negative 5 is the same thing as 1 plus 5, which is equal to 6. And on the bottom, sorry, my dog is like trying to get my attention. I'm going to subtract the two x's. So x2 is 9 minus negative 3. So negative negative again is a positive. So 9 plus 3 is equal to 12. So 6 over 12 is the same thing as 1/2. Okay, so our slope is 1/2. And then again, you're going to plug it into this formula because now you have the slope. Good. And I would just prefer to call, let me change the color real quick just so it's not confusing, x1, y1 here, because I prefer to work with positives. So you have y minus our y1 is 1 is equal to our m is 1/2, parentheses, x minus our x1 is 9. It tells us that a, b, and d have to be integers. That is important. So to get rid of this dividing by 2, I need to multiply this whole thing by 2, which allows us to cancel this out. If I multiply the right side by 2, I have to multiply the left side by 2 as well. Distribute, so I have 2y minus 2 is equal to x minus 9. And then I have to get it equal to 0, put everything on one side. So I want to keep that x positive. So I do minus 2y plus 2, minus 2y plus 2. Cancels out. So I'm left with x minus 2y. Negative 9 plus 2 is negative 7 is equal to 0. So I put it in the format that they want. X, then y, then z. Oh, I mean d. All right. Find the equation of the line parallel. So all I know is I just need to pluck this little pluck. The number in front of the x is our m, or our slope. So our m is 2. So m equals 2, I just got that, and this is our x1, this is our y1. And I want to find the equation of the line that's parallel to that point. So I have y equals, no, sorry, my bad. Y minus y1 is equal to m parentheses x minus x1. So I have y minus, here's our y1, which is 4, is equal to m, which is 2, times x minus our x1 is 1. Okay, so now I'm going to do the same thing, distribute. So this is 2x minus 2, y minus 4. I add 4 to both sides, and I get y is equal to 2x plus 2. Okay, and again, you could use the y equals mx plus b form. Just to me, it's a little bit more work. As soon as you see this word perpendicular, think of negative reciprocal. Negative reciprocal. So the negative reciprocal of this negative 1/4, make it the opposite of negative, which is positive. So our m is equal to positive, and 1/4 flipped around, or find the reciprocal of it, is just 4. So our m is 4. So I have y minus y1. Here's x1, here's y1. So y minus 3 is equal to m. So we just found out that our m is 4. X minus x1, which is negative 2, which is the same thing as negative. Negative is a plus. Distribute this, so I get 4x plus 8 is equal to y minus 3. Add 3 to both sides, and I get y is equal to 4x plus 11. Okay, good. And this one right here, you could just do using the store button, but basically 3 parentheses negative 2 squared minus 4. Plug all of that into the calculator. That's 4 times 3 is 12. 12 minus 4 is equal to 8. So final answer is 8. Largest possible domain of this function, right? Anytime ln, right? You have an ln. This number right here can never be negative, and it can never be 0. So you just go 2x minus 1 is greater than 0. To add 1 to both sides, so you get 2x is greater than 1. Divide both sides by 2, and you get x is greater than 1/2 is going to be the domain. So the largest possible domain, this is the largest possible domain. It doesn't ask us for the largest possible value. Then it says find the range when x is less than or equal to 1. So I'm going to plug 1 in here. So I have the square root of 5 minus 1, which is the same thing as the square root of 4, which is equal to 2. All right. So I know that my domain starts at, no, sorry, my range starts at 2. So if I were to graph it, it's going to look something like this. So 5 minus, it's going to look something like that. And so at 1, right, at 1, we just found out that our y is 2. So this number right here is 2. So our range is going to be from 2 and higher. Okay, it's going to be from 2 and higher. And again, if you look at the graph, you'll see a little bit better of what I'm talking about. So if you were to graph this function right here, so our range is going to be y has to be greater than or equal to 2 is going to be our range of this function. All right, so the next one right here, f of x is equal to this right here. This f negative 1 just means find the inverse. So inverse of x, when you have inverse, you're taking x and y and switching them together. So that means that this number right here, which should be our x, is actually our y. So we have f of x is y equals 4 minus 3x. So we just found out that this number here gets plugged into our y. So I have 8 is equal to 4 minus 3x. Subtract both sides by 4. Cancels out. So I have 4 is equal to negative 3x. And I am going to divide both sides by negative 3. Divide by negative 3. And I get that x is equal to negative 4 over 3. So no one stopped me. Of course, this is a recording, but still. Instead of negative 8, I plugged in 8. So this should be a negative sign, which means that this number right here should be negative 12. And negative 12 divided by negative 3 is equal to positive 4. So x is equal to 4 should be my answer for this question. I'm going to do the best I can with this question, given that it is not on a graph. So the first thing I'm going to do is draw the line y equals x, which is this right here, y equals x. And finding the inverse. The inverse means I'm going to take this graph right here, the one that they gave me, and I'm going to reflect it or flip it over the green line that I just drew. Okay, so again, forgive my lack of being able to do this 100%, but you should get something that looks like this. Okay, and move down a little bit. Okay, so the easiest way to do this is you can take your pencil, like make this dark. This is how I do it because visually it's hard for me to do this, but you can just take this right here, make it darker. Take your paper, fold it along this line right here, the y equals x, and then the pencil shaving should show you where the line should go exactly. Um, yeah, okay. This one right here can be a difficult question. So first thing we want to do is draw our x and y. So here's our x, here's our y. It tells us that it has zeros at -1. So at -1 right here, I'm going to put a 0. And at 1, 2, 3 right here, I'm going to put another 0. So the graph has to go through those points. It has a vertical asymptote at x equals 1. So vertical asymptote, I'll just go ahead and draw vertical, right? Which means that asymptote is a line that it can never cross. So there's a line right there. And a horizontal asymptote at y equals -2. So if this is -1, -2, our horizontal asymptote is going to look something like this, which means our graph can never cross those two lines. That's what an asymptote is. So if I were to go ahead and graph this, and the range is going to be greater than -2, which makes sense because, right, nothing's on the bottom. So what we're going to have is something that looks like this, okay? We're going to have a graph because it has no vertices. It's going to go something like that. And then on this side, it's going to do something similar. It's going to go through that -1, and it's going to get really close to -2, but it will never cross it, okay? So this is a sketch of the graph with those properties. Sketch the graph of da-da-da, labeling the y-intercept. So first thing you want to do is make your x and y, and again, this is a sketch, and you can use your graphing calculator to help you. So you can and should just go ahead and sketch this graph right here as best as you can. It is a sketch, it doesn't say graph. So major things that I see is at 0, -2, there is definitely a point. So 0, right, -1, -2. I'm going to make sure that there's a point that goes through that. And it looks like it goes, the graph goes up somewhere till about 2, comes down, hits that, and then goes. So let's go ahead and estimate what this looks like. It goes up, comes down, and goes something like that, okay? So this is a sketch, and it says label the intercept. So the intercept right here is at -2, okay? So just make sure. Yeah, no, that wasn't right. Let me go ahead and try this part right here again, okay? So it goes up, comes down, hits that, and then goes up, okay? That's probably a little bit better, yeah. So that -2 is our y-intercept. It's also where the minimum point is, the local min, okay? All right, so for question number 13, find the coordinates of the vertices. Vertices are max or mins, okay? So the first thing I want to do is graph it. So when I graph standard, I notice that I can't see these bottom numbers, which are the mins. I can only see this little local max right here. So I'm going to hit window, and I want to change my y min because I want to go see the bottom. So let's just make it a little dramatic and put like -30. I don't need to change anything else. So now I should be able to see the whole graph. I'm not going to do this 3 times, but I'm just going to do one with you. So you hit second trace whenever it feels like doing it. Second trace, Yep, and then I'm going to find minimum, so option number 3. So I have 2 mins and a max. So I'm just going to go find one of them, okay? I'm going to find this one right here, the one to the right. So you need to repeat this for the ones on the left and the maximum. So I'm going to go anywhere to the left of this little uh, valley thing here. So I'm going to go enter, and then I'm going to go anywhere to the right of it, okay? And I'm going to hit enter, and I'm going to go to guess where I think it is. It's somewhere around here, and I'm going to hit enter. So I found out that this point right here, so it's 3 significant figures. So 1.12, comma, and then my other number is negative 20.25, which to 3 significant figures is negative 20.3. Negative 20.3. So that's one coordinate, and you're going to find the other ones. The other ones should be negative 1 comma 0 is this point right here. And the last one right here is the same y coordinate, so it's still negative 20.3, and the x coordinate for that is negative 3.12. So I did that before. So this is a min, this is a min, and this is a max, a local, local, local everything. Local, local, local. Um, these two happen to be local and relative, right? An absolute. And this here is a local max because there's higher points. Okay. Given that the graph, given that the curve has a line of symmetry, find its equation. So the axis of symmetry is right here at -1. So this is where x equals -1. It's actually the opposite of what you think. So you would think that since it's vertical, it's y, but it's not. It's x equals -1 is going to be our line of symmetry. Find all equations, find all vertical and horizontal asymptotes. So this one, you're just going to graph it. So when I graph it, I get this. I'm going to go ahead and just put zoom standard, which is zoom 6. So it looks like, right, kind of makes like a little sad face here. So it looks like right here there is a horizontal asymptote. Okay, so to figure out what that is, I can go ahead and hit second and table, and I'm looking to see as x gets bigger, what happens to our y. So as x gets bigger, our y seems like it's going towards +1. Okay, just went away. Um, so if you look at these numbers right here, 32 over 33, right? That's almost 33 over 33, which is one whole. You could take these and put this into decimal and do it that way and convert it. Let's see how to do it. Okay, let's see if that worked. Okay, there we go, right? So we see that these numbers right here are getting closer and closer as we get larger. These numbers are getting closer and closer to 1. If I were to go second window and put like 1,000, right? And I go to my second graph, I'll see that. You see that? It's a little bit more obvious. So there is a horizontal asymptote. I'm just going to put HA, where we have y is equal to 1 is our horizontal asymptote. There are 2 other asymptotes, which looks like there are some vertical asymptotes here, right? Right here is one, right here is another one. So if I go back to second window and I change this back to 0 and I hit graph, second graph, I mean, I'm looking for where it says errors. So I see an error. Okay, I see 2 errors. One here at x equals -3. So our vertical asymptotes are at x equals -3 and x equals +2, because that's where our 2 errors are. Okay. So these are our asymptotes. Asymptotes are where the graph gets closer to that point, but never crosses. Okay. Find the zeros. This is literally just plugging it into the calculator. and looking for the zeros of the function. So if your calculator will do it for you by hitting second trace, and you're looking for option number 2, which is zeros. Ask me if you do not know how to do this. So our two zeros are going to be 0.311 and 1.92. Okay, so those are our zeros. It does say find, so we do need to show some work here. So for work, you could just say, using the graphing calculator, GDC, and looking for second calc option number, what was it? 2. Option number 2 to find these numbers. Okay. All right. For the next one, find the points of intersection. This is just literally graphing and seeing where they meet. So in blue right now is our first graph, and in red is our second. So you could literally just go ahead and sketch that graph, right? So you're going to have something that looks like these, right? And then something that looks like a straight line like that. So these 2 points of intersection right here are what we're going to label. So to do that, you hit second trace or second calc. Option number 5 is intersection. It's already close to an intersection, so I'm just going to hit enter 3 times, and it gives me the value. All right, so negative 0.467. So these are the 2 points that I got. Okay, find a linear model. So linear is, we're going to take this number, put it in for x, this number, put it in for y. So I'm going to go ahead and do that. So instead of y, I'm going to put the number 10 here. So 10 equals, I don't know what m is, so I'm going to leave that alone. Our x is negative 5 plus c. And then I'm going to do the same thing for this point. This is our x, this is our y. So I have negative 8 is equal to m times our number right here is 1 plus c. So I'm going to just go ahead and rewrite this in the right form. So I'm going to put the 10 on the other side. Negative 5 times m is negative 5m plus c. And this one, 1 times m is m plus c is equal to negative 8. So to solve this, you can definitely use the graphing calculator. So it's apps, polysymbol 2, option number 2, which is simultaneous. You have 2 unknowns, 2 variables. Hit next, which is the graph button. Plug those babies in, and then hit solve, which is the graph button. And you're going to get the answers. I'm going to show you how to do this by hand in case this is quick for you. So I can see that if I subtract these two right here, this will turn negative and the C's will cancel out. So I want to change each of my signs. So negative right now becomes a positive. So negative 5 and negative 1 is negative 6m is equal to 10 plus 8 is 18. Divide both sides by negative 6, and you get m is equal to negative 3. And you plug that in for either of those right here, and you're going to get that c is equal to negative 5. So you're going to put the whole equation together. So I'm going to plug that right back in here. So we're going to have f of x is equal to, our m is negative 3. You're going to put an x next to it, and then it's plus c, which in this case is negative 5. So plus and negative is negative. Okay. This one right here, a lot of people might think this is difficult, more difficult than it is. Here, x is equal to 3. So this first one you're only going to use when x is between 0 and 10, which 3 is between 0 and 10, so you're going to use this function right here. So we have 0.5 times x is 3 plus 11, and you're going to hit enter in the calculator, and that's going to be your answer. It's as simple as that. So that's going to give you 12.5, final answer. And then for the second one, you now have x is 11. So that's the second function, which means that x is greater than 10. So the reason why I'm not using the first one is because 11 does not fall between 0 and 10. So I'm going to use the second function, which is this. So I'm going to do 2 times 11 minus 4. Of course, my puppy needs to be as loud as possible right now. So 2 times 11 is 22, minus 4 is 18. So final answer. All right, so this one right here is very similar to the question that we did for number 17. Yep. So for this one, here's x, here's our y, here's our x, here's our y, here's our x, here's our y. So we have to plug it into here. So we have a, and our x for the first one is going to be 1. We're going to square that, plus b times 1 plus c is equal to our y, which is -3. And over here for the next one, we're going to plug in a times our new x is 2. So I'm going to do 2 squared plus b times 2 plus c is equal to 4. And the last one is a times 3 squared plus b times 3 plus c is equal to 17. Okay, so I'm going to take each of these and I'm going to rewrite them. Let's use this little teal color. Hopefully you can all see. So 1 squared times a is just a, plus b times 1 is b, plus c is equal to -3. 2 times 2 is 4, so it's going to be 4a plus 2b plus c is equal to 4. And over here we're going to have 9. 3 squared is 9 times a is 9a plus 3b plus c is equal to 17. Same thing, polysymbol 2. Okay, so apps, polysymbol 2. Option number 2, which is simultaneous equations. Plug them in, hit enter, and it gives you a, b, and c. So those are the 3 numbers you should get. A is 3, B is -2, and C is -4. So it says find a quadratic model. So low-key, that is not your final answer, right? We have to take it and plug it back into the model. So it's f of x is equal to, our A is 3, so I'm going to do 3x squared. Our B is -2, so -2x, and our C is -4. So this here is our final equation. Okay. Okay, so find a quadratic model with the following properties. So the vertex is x equals -2. The y-intercept is at y equals 9. So this low-key, it's quadratic, so this is our C. So our C is 9. Has to pass through this point. So the way I approach this problem is by remembering that vertex. The formula for finding the vertex is -b over 2a. So I'm going to take the -b over 2a, and it's telling me that the vertex is at -2. So I'm going to set it equal to -2. If there's no denominator, put a 1, cross multiply, so I have -b is equal to -4a. Okay. Divide both sides by -1, and I get b is equal to 4a. Okay. So now I use this first clue, I use the second clue, and it has to pass through this point, 1 comma 19. So I know the quadratic model is y equals ax squared plus bx plus c, and our c is 9, so I'm just going to put the 9 there. Okay, so it has to pass through 1 comma 19, so I'm going to put 19 is equal to, right, a times 1 squared plus b times 1 plus 9. And I'm going to solve this. So this is a plus b plus 9 is equal to 19. Subtract 9 from both sides. This cancels out, so I get a plus b is equal to, I don't like having this on this side, so I'm going to just put it here. A plus b is equal to 10. Okay, so now I know that b is equal to 4a. So wherever I see a b, I can plug in 4a here. So I have, I'm going to take this here. So I have a plus, my new b is 4a, is equal to 10. So 1a plus 4a is 5a, which is equal to 10. Divide both sides by 5, and I get a is equal to 2. So if a is 2, then to find b is going to be 4 times, right? Remember this? B is equal to 4 times a, so 4 times 2, which is equal to 8. Okay, so now my final answer is, got to do this in black, it's going to be f of x is equal to, my a is 2, so it's going to be 2x squared. My b is 8, so it's going to be plus 8x, and my c is 9. Okay, and I know that from here. Good. So this is my whole answer. Alrighty. So this one here here's my x, here's my y. Once you do enough of these, you'll be like, okay, I get it. So we're going to just plug some babies in. So we have k times 3. Oh, by the way, this here is a typo. This should say -1. Okay, so put a -1 there. I'm telling you now. I know I didn't tell you earlier. The book made a mistake. All right, so getting back to the problem, minus x plus c. That's our formula. This is f of x. So now I'm just going to plug in what it is that I know, okay? So I know that this is my x, this is my y. So I'm going to do 38 is equal to, I don't know what my k is, times 3 to the, I have -2 plus c. And then I'm going to do the same thing for this one, okay? So I have 14 is equal to k times 3 to the -1 plus c. I'm going to go ahead and take this baby right here, and I'm going to make this simpler. So negative negative becomes a positive. 3 to the second power is 9. So I have 9k plus c is equal to 38. And I'm going to do the same thing here. Negative negative is a positive. 3 to the first is 3. So I have 3k plus c is equal to 14. You can polysymbol to this, or you could just subtract these. So this is going to be 9 minus 3 is equal to 6k. So 6k is equal to, this is going to subtract, this is going to cancel out. 38 minus 14 is 24, and I get k is equal to 4. Okay, divide both sides by 6. So k is 4. So now I can go ahead and write down what it is that I know. So I have f of x is equal to, right, my k is 4. So I'm going to do 4 times 3 to the negative x plus c. So I can use my other equation. Yeah, so I forgot a step. If you polysymbol to this, or you take the k and plug it back in here to either one of these, you'll get that c is equal to 2. So we have plus 2, right? Because everything else, this right here is our k, this is our c. So this is our equation that it becomes, okay? Alrighty, sketch the graph, label the x-intercept and the asymptote. So I have my x and y axis here. I'm going to sketch this, which means that our calculator comes in handy. So you're going to get something when you sketch it. Look at the graph. You're going to get something that goes through 0, 11. And remember, asymptote means that this graph never crosses that line. So you're going to just draw as close, it gets close to it, but not ever crosses it. So I labeled the axis intercept, right, which is right here, and I labeled the asymptote, okay? So if you want to be more specific, you can say y equals 3 is your horizontal asymptote, and the intercept is going to be 0, 11, which is our y-intercept, okay? All right, question 23. Y is inversely proportional to the square of x, okay? So if it just said to x, I could write y is equal to k over x, but since it says the square of x, it's going to be k over x squared. So it says given that y is 3, so I'm going to take 3 is equal to k over, and x is 2, so I'm going to do 2 squared here. Find the relationship between x and y. So I have, this is 4, cross multiply here, so that's going to give me 4 times 3 is 12, so I'm going to get k is equal to 12. So then I'm just going to put it back into this form right here. So I have y is equal to, my k is 12 over x squared. Okay, this is my final answer. Sketch the graph stating the equations of all asymptotes. I think we've done this enough. And you should get something like this, right? You're going to get two graphs, never crosses the x-axis or the y-axis. They approach it, and these are our asymptotes, okay? Cubic model, again, we've done this a lot. Yeah, we've done this a lot. This is exactly the same thing, right? Plug it in, polysymbol 2. Let me know if you have questions about this. I should just do this, but 34 minutes. Okay. I'll just show you what I did before. So I plugged in my A, right, my X and my Y, and I got this right here, right? You can pause the video and just make sure that you check your work. Please don't just copy from what I did. And then negative 2 to the third power is negative 8a. This is 4. This becomes 4b. Negative 2 times c is negative 2c. You bring the d is equal to 1. Put this into polysymbol 2, and you'll get a is 2, b is 1, c is negative 5, d is 3. And then you plug it back into the original function. Okay, this is exactly like 17 and 19. All right. All right, so now we get into the fun stuff. So find a model of the form, with the following properties, okay? So model of the form. So our amplitude is 4, so our A is 4 is what that's telling us. The period, the formula for period, so period is equal to, in radians, it's 2 pi over b, and in degrees, 2 pi is the same thing as 360, so 360 over b, okay? And our principal axis is y equals negative 1. So we'll get to that. So that's going to be our d. So our d is equal to negative 1. So now we're going to put everything together, okay? So they told us that the period is 240. So this is the only one that we have to do a little bit of work in, okay? So the period is 240, so we're going to put 240 is equal to, we're not working with radians. We actually are working with degrees, right? So you're going to use this part of the formula. So 360 over b. So we want to find out what b is over 1, right? So to figure this out, you cross multiply. So you get b times 240, or 240b is equal to 360. Divide both sides by 240. Divide by 240, divide by 240, and you're going to get b is equal to 3 over 2. Okay. All right, so now we have our A, we have our B, and we have our D. So therefore, our model is going to be f of x is equal to, our A is 4, right? That's our amplitude. So 4 sine, our B is 3 over 2. So I'm going to put 3 over 2. You're going to put an x next to it. And then you're going to put plus D, which is minus 1, okay? All right, and just put a box around that. Next one, following data are collected. Okay, so this is something that you do need to know how to do. So I'm just going to go ahead and clear my calculator. Second plus 712. You should write this in your study guide if you didn't know that. So we're going to do something called stat, and we're going to plug these numbers in here. So stat edit, and I'm going to plug the numbers that we have. So this is 0 through 4. So 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. And again, you should be doing this. Don't just watch me do this. Across from 0, I have the number 5. Across from 1, I have 2.5. Okay, I'm just putting these numbers in. 1.25, 0.625, 0.3125. Okay. So once you put this in, the next thing we're going to do is, you see we're in blue right here, it says stat plot. So I'm going to hit second y equals. I'm going to turn my first plot on. So press option number 1, and I'm going to change this to on. And now if I hit graph, I should be able to see what this looks like. Okay. So this looks like it's exponential decay. So it's not a line. Okay. It's not a quadratic, because this is a line. This is a quadratic. It's not either of those. A divided by x, if you are not sure what that looks like, if you do like 5 divided by x, you're going to see that the graph looks something like that, okay? So because it has two parts right here, and I can also say over here, see this? This is an asymptote for a over x. See that? So there's an asymptote here, and there's an asymptote here. Like if I get closer and closer to the right, you can see that it never crosses to the negative sign. Whereas over here, I can tell that since this point right here, 0 across from 0 is 5, there is no, not sure what I say, there is no vertical asymptote here. So if I go ahead and clear this, there's no vertical asymptote for my original data, right? Because again, it crosses right here, okay? So this cannot happen because this has an asymptote here and here. Um, so the only one that's left is this right here, and this is determined, this is the most appropriate, because there is no vertical asymptote, no VA, yeah, in the data. Okay, so that's how you know it's not the other ones. Determine the values of the parameters. So to do that, I'm going to use my first two numbers, so 0, 5, and 1, 2.5. So 0, comma 5, and 1, comma 2.5. So I'm going to plug that. Here's our x, here's our y, here's our x, here's our y. So I'm going to plug that into our equation. So I have y equals, right? So 5 equals, I'm going to plug it in here. So k times 2 to the r x, and our x here in this first case is 0. So times 0. And then I'm going to do the same thing here. So I'm going to get 2.5 is equal to k times 2 to the r times our x is 1. Okay, so I'm going to simplify this real quick. So or any number times 0 is just 0. 2 to the 0 power is 1, right? 2 to the 0 power, you can use your calculator. So this whole thing right here is going to equal 1. So I have 1 times k, which is k, equals 5. So I just figured out what my k is. My k is. So now that I figured out what my k is, I can use that, and I can take this 5 right here, and I could plug it in here. So I have 2.5 is equal to, my k is 5, times 2 to the r, and I know that my x is 1, so I'm going to put times 1. So this is 2 to the r. So this is 5 times 2 to the r is equal to 2.5. You could plug this under y1, plug this under y2, see where they intersect. Or if you want to do it algebraically, you divide both sides by 5. Divide this by 5 as well. So when I do that, I get 2.5 divided by 5 is equal to a half. This cancels out, so I'm left with 2 to the r. Plug this into the calculator, so y1, y2, and you'll get that r is equal to -1. So r equals -1. So we found out r and we found out k. Okay, so r equals -1 and k equals 5. Good. Oh Lord. So publisher, blah, blah, percent for newly published book. S is the percent for the market share. So our S percent has to be less than 100. Got to keep that in mind because you can't go over 100%. So it can be less than, or it could equal exactly 100%. So I put 3x plus 4 is less than or equal to 100. Subtract 4 from both sides. So I get 3x is less than or equal to 96. Divide both sides by 3, and you get x is less than or equal to 32. Okay. There's also a restriction or a suitable domain because you can't get below 0, right? So x, which is our the thousands of dollars, right? This is going to fall between, the x is going to fall between 0 and 32. From this function, you find the predicted market share when 18,000. So this is where x is equal to 18, right? Because it's in thousands of dollars. That's what it says. So I'm going to plug that into the formula that they gave us, which is 3x plus 4. So I have 3 times 18 plus 4. Hit enter in the calculator. What is that? That's a z. Hit enter in the calculator, and you are going to get, that is going to equal 58. In this case, it's percent. So 58%. Okay. State 2 reasons why the model in question 29 is unrealistic. So a linear model, 3x, right, plus 4, is not realistic for market share, is unrealistic. And then also to get 100% of market share is also unrealistic, okay? Is also unrealistic or not realistic. Okay, all right. It is late. Sorry, don't have a lot in me. Suggest an improved model. Mm. So an improved model is like, if you look at the market share, it shouldn't just go down as a line. It should actually like decay over time. So this is an exponential function. Quite specifically, it's a decay function. So y equals a parentheses 1 minus r to the t is one model that you could use. Or you could say, like, be more specific, and you could say y equals c minus a to the negative x because we want it to decay, and you can say that c has to be less than 100. That could be an improvement. All right, this is a very long time. It is, I don't know if you can tell, but it is 8:04 p.m. I'm getting tired. I have to get up at 4 a.m. to see you all. I love you guys. I hope that this made sense. Get ready for your test. Okay, thank you.